are going to look at the reactivity of indole, benzofuran, and benzothiophene. So, at the end of the session, you should be able to state the types of reactions indole, benzofuran, and benzothiophene undergo. Right? You should be able to explain why electrophilic substitution in indole occurs at carbon number 3. You should be able to write equations to represent electrophilic substitutions in indole, benzothiophene, and benzofuran. Okay, so we will begin with the electrophilic substitution reactions, and first of all, we are going to consider indole. Now, electrophilic substitution reaction takes place on the 5-membered ring because the 5-membered ring is strongly activated towards an electrophile than benzene. An electrophilic substitution of indole occurs at the carbon number 3 position. So, because the indole is basically comprising two aromatic compounds, we have a 6-membered ring here, which is benzene, and the 5-membered ring, this pyrrole. Both of them are activated towards an electrophile, right? However, the 5-membered ring is strongly activated than the 6-membered ring. So the incoming substituent goes to the 5-membered ring and it goes to carbon number 3, right? And whenever the carbon number 2 goes to carbon number 3, yeah, and whenever the carbon number 3 position is already blocked, then the incoming substituent is forced to go to position 2 on the first same 5-membered ring, right? Now the reason for this was partly described in the previous session, but if you look at the reason why the incoming electrophile prefers to attack the third carbon in the next slide. So let's quickly look at that. Okay, so when both this also another thing we would like to just throw more light on. So when both carbon number 3 position and carbon number 2 positions are blocked, then the substituent is forced to the second ring, which is the benzene ring at carbon number 6, right? So this is 1, 2, 3, 4, 5, 6. It goes to the second ring, right? Now the difference in orientation of the substituents can be explained by comparing the stabilities of the carbocation intermediates obtained in the electrophilic attack at carbon number 2 and then carbon number 3. So let's quickly look at that. So these are the resonance structures that are produced. So at carbon number 2 position, these are the resonance structures that are produced. And if you look at all these resonance structures, it's only the first one that is relatively stable. Now when we say relatively stable, we are trying to imply that it's in only this structure that we have the benzene ring fully having its aromatic pi electrons, right? So this is relatively stable. However, all the others have our benzene ring not fully aromatic, right? So that is one. And if you look at the relative stabilities of the resonance structures produced at carbon number 3 position, realize that this benzene ring is fully in its aromatic state. Similar thing is seen here. So realize that even out of just the 2 resonance structures that are produced at the electrophilic attack at carbon number 3, all those 2 resonance structures are relatively stable compared to the 5 relative resonance structures that are produced at carbon number 2. So basically, substitution at carbon number 3, which produce these 2 stable intermediates, leads to the production of more stable products, right? So it's always an attack at carbon number 3 and not an attack at carbon number 2. So the incoming electrophile only attacks the second carbon on the 5-membered ring when the carbon number 3 position is what's already blocked. So let's keep note of that as well. Okay, so next we can quickly look at other reactions of indole. So just as we talked about in the previous session, you see indole resembles pyrrole in many of its chemical properties, and because of that there are certain chemical reactions that pyrols undergo. So if you look at some of the reactions we talked about in pyrrole, with that pyrrole undergoes, you realize that some of these chemical reactions are similar to what indole also undergo. So substitution occurs at carbon number 2 if the third position is already blocked, and similarly, when the second carbon position and third carbon positions are also already blocked, the third incoming substituent is forced to the second ring, which is the benzene ring, at carbon number 6. Now, indole also undergo the managed reaction. The managed reaction is typically between your reactants. So in this case, we have our starting material, our indole, which reacts with formaldehyde in diethylamine, right? So these three chemicals, when combined, leads to the production of our manic adduct, right? The manic adduct is produced as well. So this is another reaction that indole undergoes, the manic reaction. So please don't forget about that. Okay, so the next two other reactions of indole that we are going to look at is the imine-enamine tautomerism that it undergoes, as well as its electrolytic reduction. So these indoles can be reduced electrolytically to produce this. So we have our double bond being reduced to this structure known as 2,3-dihydroindole, also known as indoline. And you also have its imine-enamine tautomerism, where the indole is reduced to indolamine, right, or indolamine. So these are the two other reactions we can add to the managed reaction. So with that being said, we'll move on and look at the electrophilic substitution reactions in benzofuran, right? So we are done with indole. Let's quickly look at what happens in benzofuran's electrophilic substitution reaction. Now, just like indole, the substitution of benzofuran at carbon number 2 produces only one relatively stable resonance contributor out of all the 5. So just like in indoles, out of all the 5 resonance contributors that we can get out of benzofuran, only one is relatively stable, right? And similarly, 2 resonance structures are also produced at substitution at carbon number 3, but the issue or the difference here is the fact that in the relative stability of these 2 resonance structures, only this is stable, only one is stable. So out of the 2 resonance structures we can obtain at substitution at carbon number 3, only one is stable. The reason is that oxygen is highly electronegative, right? Oxygen is more electronegative than nitrogen, and as a result, whereas nitrogen can tolerate a positive charge, oxygen cannot. So because of that, out of the 2 resonance structures that are produced, only one is relatively stable. This therefore means that in any electrophilic substitution reaction of benzofuran, the substitution occurs at position 2. That is the carbon number 2 position. So benzofuran is able to produce 5 resonance structures at attack at carbon number 2, and out of the 5, one is relatively stable, and then at attack at carbon number 3, out of the 2 resonance structures that are produced, only one is relatively stable, and because oxygen is highly electronegative, it does not tolerate a positive charge, which makes attack at carbon number 3 in benzofuran less likely. But a substituent or an incoming electrophile prefers to go to carbon number 2 because the resonance structures produced at carbon number 2 are more stable. So the oxygen atom is more electronegative, just as I said, than nitrogen, and as a result cannot tolerate the positive charge. So this is what happens. So this is not stable, this is relatively stable, right? So between the 2 resonance structures that are produced at carbon number 2 position, for benzofuran, this is relatively unstable. However, substitution reaction or the electrophilic substitution reaction in benzothiophene, right? Now, benzothiophene undergoes electrophilic substitution reaction equally at carbon number 2 and carbon number 3 positions. So the two carbocation intermediates are closely related in stability. So when there's an incoming substituent, the incoming substituent can go to carbon number 3 position or the carbon number 2 position, which means that the 5-membered ring is strongly activated towards the incoming electrophile, and both sides are possible. So the incoming substituent can go to carbon number 3 or can go to carbon number 2, unlike what is observed in indoles and then, of course, benzofuran.